Okay, so continuing from the previous video, let's check these calculations. So it was actually here it was because 2, 3, 4, and then it should be 5. It does not look like 5 here, so it should be 5. So it should be 2 divided by 2, so it will be, I think it will be minus 3a naught. Yeah, so it should be minus 3a naught, 3a naught. And this will be, yeah, 2 by 3 a1, and this will be 0, and this is yes, 6 over 5 into 4. So this should be 3 by 10. Okay, 3 by 10 a3, and then when we put the value of a3, which was 2 by 3, it was minus 2 by 3, so it will be minus a by 5, right? It should be a by 5 minus a1, because 2 by 3 and then 3 by 10, so 2 by 3 into 3 by 10, so it should be 1 by 5. Okay, so it should be minus a1 by 5 minus 5, which should be minus 5. Okay, so let's write these polynomials, these power series. So y of x is equal to a naught plus a1 x, and then a2 term will be this minus 3a naught x square, and then this term is minus 2/3 of a1 minus 2/3 of a1 x cube, okay, and plus 0, okay, plus 0 x4, and then this term will be minus a1 by 5 x power 5 minus a1 by 5 x power 5. So it will be minus a1 by 5 x power 5. Okay. Okay, so we can write even more terms, but I think what we want to know is that there are two solutions here. One of the solution is starting from this these even terms, okay, and this solution is like with the a naught, so 1 minus 3 x square, and then plus 0, and then likewise the x power 6 will be also 0. So this a naught term, because why x power 6 will be 0, because this after this the a6 will depend on a4, but a4 was 0. Similarly a8 will depend on this previous 0 value, so this series will terminate here, okay, and then y2 of x is the other series with the a1, then x minus 2/3 of x cube minus 1/5 of x power 5. So this is an infinite series. So however, in this this finite series, which is basically the polynomial, Legendre's polynomial, is the polynomial for n is equal to 2. Okay. Generally speaking, this polynomial is written with the value of a naught is equal to minus a by 2, generally speaking, and then if we put this value over here when arbitrary constant is taken as -v/2. So this Legendre's equation for the second degree will be then equal to, this will be equal to 1/2, then 3x square minus 1. Okay. So in this way we can find the polynomials, Legendre's polynomials, by repeating these calculations. However, there is a formula as well, but by using that formula we can directly find the Legendre's polynomial for any degree. Okay. And that formula in fact simplifies the calculations. So one thing you can note from this is that in this case the value of n for the Legendre's equation was even, and in this case the value of n is equal to 1. So when the value of n was odd, which is 1, we got the solution from the odd power of x. However, when the value of n was even, so we got the solution from the even powers of x. Okay, so that means the series in the even powers terminated after the second term in this case. So this is one of the observation which can be very useful for further derivation of the Legendre's polynomials. So as I have told that there is a formula, or of course there are more than one formula to calculate this the Legendre's polynomial. As we can see that in these two examples, it is quite tedious to calculate the Legendre's polynomial by these coefficients method. However, if we use a formula such as that provided by Rodriguez, okay, Rodriguez formula, then the task becomes quite easy. So what is that formula? That formula says that if, for example, if we want to find the polynomial of any order k, Legendre's polynomial of any order k in terms of x, so we can find it by this. So it will be 2 power k k factorial, okay, or k factorial. It will be the kth derivative of this term, x square minus 1 power k. Okay, so let's verify two of our results. So we know that p1 of x is just x, so whether it will be, whether this, we can check it. So first of all, we can find x square derivative of x square minus 1. So first of all, we will write this term x square minus x square power 1. So we have to take its derivative. So in this case, k was equal to 1. So we will just need to take the first derivative of this term. So that will be 2x. Okay, and then 2x, and then after that we have to divide by 1 power 2k over k factorial. So 2 power 1 into k, which is 1 factorial. So 2 cancels with 2, so we get x. So that's what we know. So, and what is the polynomial second one, which we just found out over here? Okay, so let's see whether we can get the same answer. So for this, what we do is we take x square minus 1 power 2, and then we take its derivative. So it will be 2 into x square minus 1 into 2x. So we can simplify it. So it will be 4x cubed minus 4x square. Okay, 4x square, and then take the derivative again the second time. Okay, the second time. So it will be 12x square minus 4. Okay, and now this has to be divided multiplied by 1 over 2 power k into k factorial, so it is 2 factorial. So but this is 4 into 2, it is 8. So we can take 4 common from a numerator, so it will be 3x squared plus minus 1 over 8, so it will be 1 over 2, so which is the same answer which we got before. Okay, so this is the polynomial of Legendre's polynomial of second order. So let's do one more example for Legendre's polynomial for the third order. So in this case, what will be that value? Okay, so we'll take x squared minus 1 cube, okay, and then we will take its derivative. Okay, so it will be 3 into x squared minus 1 square into 2x, so this will be 6x into x squared minus 1 square. Take its derivative again, so it will be, we can apply the product rule, so 6x into 2 into x squared minus 1 into 2x, and then 6 into x squared minus 1 square. So okay, so in this case now it will be 2x, so it will be 2, okay, 6 times 2 is 12, times 2 is 24, 24 x squared into x squared minus 1, and plus 6 into x squared minus 1 square. Okay, so we can further simplify it, so it will be 24x power 4 minus 24x square plus 6 into x square minus 1 square. Okay, so again we need to take its derivative for the third time, first time, second time, and now third time, because k was equal to 3. So it will be 24 times 4 is 24 times 4 is 96 x cube minus 24 times 2 is 48 x, and then it will be 6 times 2 is 12 x squared minus 1 into 2x, so that will be the derivative. So we need to simplify it. So it will be 96x cubed minus 48x plus 12 x. 12 times 2 is 24 x cubed, 24x cubed, and then 24x minus 24x, right? 12 and 24x minus 24x, so it will be 96x cubed, and then minus 72x plus 24x cubed, so for plus 24x cube, yes, okay, so I can add this to that, so 96 plus 24 is 120, so it will be 120x cubed minus 72x. So what I can do is I can take something common between them, so which is actually 24. 24x I can take common, or just take x as common, 24, and then this will be 5x cubed minus 3. Okay, so now this and the outer term was 2 power k, 2 power 3 into 3 factorial, so this term is 8 by 6, and then it will be 24 into 5x cubed minus 3, so this will be 4, this will be 2, so it will be 1 by 2, 5x cubed minus 3. So this will be the polynomial of Legendre's polynomial of third order. Okay. It will be 3x and 3x. Okay. So in this way we can find the Legendre's polynomial. So although you can see that even in the case of the Rodriguez formula, the calculations become a little bit lengthy because of